For my presentation, I was given the molecule C11H12Cl2 N2O, also known as lofexidine. For the H&MR, the first set of protons that we will look at is highlighted on the screen. These protons show up at about 1.5 ppm and produce a doublet. The next set of protons fall in the range of 3.4, and that produces a doublet of doublets. The next set of protons is in the same ring, and they show up around 3.85 ppm, and they also produce a doublet of doublets. The next proton that we will look at falls in the range of 4.83. This produces a quartet. The next highlighted protons fall in the range of 7.56, and they produce a doublet. And the last proton falls at 7.36 ppm and produces a triplet. For the carbon NMR, the first carbon we'll look at here, it falls at 18.3 ppm. The next carbon is at 49.4 ppm, and this carbon is not chemically equivalent to the previous carbon highlighted. However, it does fall in that 49.5-ish ppm range, as you can tell from the spectrum. The height of the peak shows an integration of 2, even though at the top of the peak at 50, it only shows 1. This next carbon is located at 73 ppm. These two chemically equivalent carbons fall at 129 ppm. This next carbon is at 125 ppm. The next two chemically equivalent carbons are located at 127.7 ppm. The carbon attached to the oxygen is located at 147.8 ppm. And the carbon located in the ring with the 2 nitrogens is located at 152.9 ppm. Now moving on to the COSY, which allows us to understand interactions between protons that are interacting with each other throughout the molecule. And as you can see from the carbons labeled in the structure, the protons on those carbons interact according to the lines drawn in the COSY spectrum at roughly 4.3 ppm and 1.5 ppm. The next two carbon atoms that have protons that interact with each other are drawn on the COSY again, and those are the protons that fall in the range of 3.4 and 3.8 ppm. And the next group of carbons that have protons on them that can interact are depicted in the bottom left-hand corner of the COSY. And you see 2 sets because the 2 carbons are equivalent, interacting with that carbon on the end, or the hydrogen atoms on that carbon on the end, at around 7.4, 7.5 ppm. For the HSQC, this gives us information about the connectivity between carbons and the protons. From the lines drawn on the HSQC, you can see that the carbon located at 18.3, the only CH3, in the molecule interacts with the protons the proton near 4.83 ppm, and you can see that that the carbon that is located, the two carbons that are located at 50 ppm interact with the protons that are located in the 3.4 ppm range and 3.9 ppm range. And for the IR spectrum, you would expect to see a medium stretch between 3350 and 3310 from the secondary amine. You would see medium stretching between 3100 and 3000 from the alkene. You would see medium stretching from 3000 to 2840 for the alkane. For the aromatic ring, you would see a weak bending between 2000 and 1650. For the amine group, you would see medium stretching between 1690 and 1640. And for the halo compound of the carbon attached to the chlorine, you'd see strong stretching in the fingerprint region between 850 and 550. For the elemental analysis of this structure, your 100% purity percentages would be carbon equaling 50.98% of the molecular weight, hydrogen would equal 4.63%, nitrogen would equal 10.81%, the chlorines would have 27.04%, and oxygen would make up the last 6.18%. As for the stereocenters in this molecule, there only happens to be one, and this stereocenter has the R configuration. And in terms of J values, the only unique J values that I found were the J values seen in the protons in the ring, the 5-member ring containing the two nitrogens. The J values for the protons nearest the NH had 12.1 hertz as the highest J value. However, the J values for the protons located nearest the N double bonded to the carbon, the highest J value was 16.2, and my assumption is that there's geminal coupling with the protons in that 5-membered ring.